There's 5 main types of reactions that we're going to be talking about: synthesis, decomp, single replacement, double replacement, and combustion. In a synthesis reaction, you're putting things together to get one product. So the general formula is A plus B yields AB. When you're putting them together, you have to pay attention to the charges. So K plus Cl. Potassium has a +1 charge. Chlorine has a -1 charge. So those go together, KCl. This is the skeleton equation. It is not balanced. So that is why we do not bring over that 2 like so, because potassium and chlorine do not go together in a 1:2 ratio. They go together in a 1:1 ratio based on their charges. The reason chlorine has a 2 over here is because it's diatomic and can't be by itself. Potassium's not diatomic, and that's why it's by itself on the left side. Then you can go back and balance the skeleton equation by saying I have 1 potassium on the left, 1 potassium on the right. I have 2 chlorine on the left, so I need 2 chlorine on the right, which then changed my potassium, so then I need a 2 over here. Now it's a balanced equation. And notice now our chlorines are equal on both sides. But you have to stop and pay attention to how the charges go together when it's a metal and a nonmetal. On example B, we have sulfur and oxygen. Sulfur is a -2 and oxygen is also a -2. They're both nonmetals. So we're going to make a covalent compound. With what you know right now, as long as you put those 2 together, then that will be correct. The correct answer is actually sulfur dioxide. But if you put sulfur trioxide, that's fine as well, because those are not going to ever get their charges to cancel out. So then we make sure it's balanced, and it is balanced. Decomposition is the breakdown of one reactant. So you're going to start with one thing, and it's going to break apart into two things. The only one that you're going to have to be able to predict the products for is a binary compound, which means 2 elements, not including a polyatomic ion, because polyatomic ions in a compound would make it have more than 2. So H2O, the 2 elements that make that up are hydrogen and oxygen. The only thing you have to pay attention to is if they're diatomic. Hydrogen is one of the 7, so we need a 2 there. And oxygen also is diatomic, so we need a 2 there. So they have 2's there because they're diatomic, not because it had a 2 on the left side. So this is our skeleton equation, and then we can go back and balance that. We have 2 oxygen on the product, so we need 2 oxygens on the reactants. But now we have 4 hydrogens, so now we need 4 hydrogens over on the products. Aluminum chloride is made up of aluminum and oxygen. Aluminum is not diatomic, so it does not get a number on the bottom, but oxygen is diatomic, so we put the 2 there. Do not just break it apart and say Al2 plus O3. That will be incorrect. You will get no points for that. So this is our skeleton equation, and then we look at it and say I've got 2 oxygen and 3 oxygens. I can't get the products to become 3, so I need the lowest common multiple. So I can put a 2 here and a 3 there, so both sides have 6. And then my aluminums, I've got 4, so I need a 4 here. For synthesis and decomp, those are the only 2 kinds of examples you would see on a test or quiz or worksheet. But if I ask you to identify if something is a synthesis or decomp reaction, it may not be a simple one like the ones that you're predicting. You'll know that it's a decomp reaction because you'll have 1 reactant. And you'll know that it's a synthesis reaction because it'll have 1 product. A combustion reaction means burning. So in order for something to burn, it undergoes a combustion reaction. A hydrocarbon plus oxygen is burned, yielding carbon dioxide and water. So sometimes they'll say C6 plus H6 is burned in air. Or it'll say C6 plus H6 plus oxygen. So notice that if it's saying burned in air, you are adding oxygen to the reactants. A hydrocarbon, hydro is hydrogen, carbon is carbon. So this is a hydrocarbon. This one is also a hydrocarbon, even though it contains oxygen. So that will also undergo a combustion reaction. So once you recognize that it's a combustion reaction because you have a hydrocarbon and oxygen as separate reactants, then the products are always the same. You're going to have carbon dioxide and you're going to have water. For the bottom reaction, it's a combustion reaction. So we're going to have carbon dioxide and water. I'm going to pause the video and try balancing these two on your own. Combustion reactions are a little bit more difficult to balance, but remember to leave your oxygen and hydrogen to the end. Restart when you have your answer. So when starting, you had 6 carbon, 1, 6, 2 hydrogens, and 2 and 3 oxygens. First, I balanced my carbons. So I've got 6, and then my hydrogens. And then I've got 12 plus 3 is 15 oxygen. Notice there's no way I'm going to get 15 oxygen on the reactant side. So if I double everything, so I put a 2 here, 12 here, and a 6 here, then that would give me 12, 12, 12, 12, and that would give me 24 plus 6 or 30 hydrogens because everything got doubled. Now I can put a 15 here and it's balanced. So if it's not working, if you get bigger numbers by doubling everything, then sometimes that causes it to work out. So this is what we have for this bottom reaction. And so first I balance my hydrogens, because my carbons are already good. And now I've got 4 hydrogens. This one's different than the top though, because I have oxygen in more than one spot. And notice that this is the one that's causing it to be odd. So I've got to put a 2 here to get the reactants to be even. So that's 2. Which then messed up my hydrogens and my carbon. And now I can fix my oxygen. So I've got 2 here, so I need a 3 here. So be careful when you have oxygen in more than one spot. Don't just quickly look at it and be like, oh, I need a 4. Nope, I already have 2, so it's 2 plus something gives me 8. And so it should be 2, 3, 2, 4. I'm going to pause the video and try this one on your own. Restart when you have a balanced equation.